This video contains audio content only. There are no visual elements or images accompanying the audio. If you're expecting to see video footage, please note that this is an intentional audio-only presentation. We recommend listening to this content rather than watching the screen. Thank you for your understanding and enjoy the audio. Welcome to an exploration of one of nature's most fascinating and deceptive strategies, brood parasitism. In this easy-to-understand journey, we'll uncover the secrets of these cunning creatures who have mastered the art of outsourcing parenthood. Get ready to delve into a world of manipulation, mimicry, and evolutionary arms races, where the survival of the sneakiest reigns supreme. Brood parasites, found across a diverse range of animals including birds, insects, and fish, have evolved a remarkable strategy for reproductive success. Instead of raising their own young, they trick other species into doing the hard work for them. Imagine a tiny bird tirelessly feeding a chick many times its size, completely unaware that it's raising an imposter. This is the world of the brood parasite, a world where deception and exploitation are the keys to survival. We'll begin by unveiling the sneaky lives of these parasitic masters, exploring the diverse tactics they employ to infiltrate the nests of unsuspecting hosts. From the subtle art of egg mimicry, where parasitic eggs evolve to resemble those of the host, to the more brutal tactics of chick manipulation and even siblicide, we'll uncover the ingenious strategies that allow these parasites to thrive. But the story doesn't end there. Hosts, facing the constant threat of parasitism, have evolved their own defenses, creating a dynamic evolutionary arms race. We'll explore the counter-strategies employed by hosts, from egg recognition and rejection to nest desertion and even aggressive defense. It's a constant battle of wits, where each adaptation by the parasite is met with a counter-adaptation by the host, in a never-ending cycle of evolutionary one-upmanship. Prepare to be captivated by the chilling implications of the Mafia hypothesis, a theory that suggests some parasitic birds enforce parental care through intimidation and retaliation. Imagine a world where the price of rejecting a parasitic egg is the destruction of your entire nest. We'll explore the evidence for this chilling theory and its implications for the complex relationship between parasite and host. Finally, we'll broaden our perspective to examine the wider ecological impacts of brood parasitism. From the reduction in host reproductive success to the influence on host distribution and abundance, we'll explore how these parasitic interactions shape biodiversity and the ecological dynamics of entire communities. We'll also delve into the concept of the evolutionary trap, where once adaptive behaviors become detrimental in the presence of brood parasites. By the end of this exploration, you'll have a deeper understanding of the fascinating world of brood parasitism. You'll appreciate the intricate adaptations of these deceptive creatures, the ingenious defenses of their hosts, and the broader ecological consequences of this remarkable evolutionary strategy. Get ready to be amazed, intrigued, and perhaps even a little disturbed by the sneaky lives of the brood parasites. Chapter 1. The Sneaky Life of the Brood Parasite. The world of nature is full of surprises, and few are as intriguing as the deceptive tactics employed by brood parasites. These cunning creatures have mastered the art of shirking parental responsibilities, outsourcing the demanding task of raising their young to unsuspecting hosts. This strategy, known as brood parasitism, is a remarkable example of evolutionary adaptation, observed across a diverse range of animals, including birds, insects, and fish. It's a story of manipulation and survival, where the parasite's success comes at the expense of its unwitting host. Picture a bustling rufous-collared sparrow nest, a haven of parental care where tiny chicks eagerly await their next meal. Amidst this flurry of activity, a much larger, imposter chick stands out. This is the offspring of a shiny cowbird, a brood parasite that has exploited the sparrow's parental instincts. The size difference is striking. The cowbird chick dwarfs its foster siblings, yet the sparrow parents remain oblivious to the deception, diligently feeding the enormous intruder as if it were their own. This stark contrast highlights the cowbird's manipulative prowess, showcasing how it capitalizes on the host's ingrained drive to nurture its young. Travel to Brazil, and witness another act of parasitic deception unfolding in a vibrant tropical setting. A masked water tyrant, a small flycatcher, tends to its nest, unaware of the impending threat. A shiny cowbird, its plumage shimmering in the sunlight, lurks nearby, patiently waiting for an opportunity. The cowbird's objective is simple: to deposit its egg into the tyrant's nest, ensuring its offspring will be raised by another. The cowbird monitors the tyrant's activity, carefully observing its foraging patterns and nest visits. When the tyrant leaves the nest unattended, even for a brief moment, the cowbird seizes its chance. With swift precision, it enters the nest and lays its egg, a deceptive act that sets the stage for a parasitic takeover. These compelling narratives illustrate the diversity and ingenuity of brood parasitism. The parasites, often of a different species than their hosts, employ a range of tactics to ensure their offspring's survival. Egg mimicry is a common strategy, where the parasite's eggs evolve to resemble those of the host, increasing the likelihood of acceptance. This form of aggressive mimicry, known as Kirbian mimicry, is a crucial adaptation in the brood parasite's arsenal. But why do brood parasites resort to such deceptive tactics? The answer lies in the significant evolutionary advantages this strategy offers. By outsourcing parental care, brood parasites free up valuable time and resources that can be invested in other activities crucial for their survival and reproductive success. Instead of dedicating weeks or months to nest building, incubation, and chick rearing, brood parasites can focus on foraging, replenishing their energy reserves, and seeking out new mating opportunities. This increased foraging time allows them to accumulate the resources needed to produce more eggs, maximizing their reproductive output. While quantifying the exact increase in offspring production is complex and varies between species, studies have shown that brood parasites can lay significantly more eggs than their non-parasitic counterparts, sometimes 2 or 3 times as many in a single breeding season. The diversity of brood parasitism extends beyond birds. Insects and fish also exhibit this remarkable behavior, showcasing the widespread nature of this evolutionary strategy. In the insect world, certain species of cuckoo bumblebees infiltrate the colonies of other bumblebee species. These parasitic bees, lacking the worker caste of their hosts, rely entirely on the host colony for rearing their young. They kill or subdue the host queen and manipulate the host workers into caring for their own brood, effectively hijacking the entire colony's resources. Among fish, the cuckoo catfish of Lake Tanganyika provides a fascinating example of brood parasitism. These catfish target mouth-brooding cichlids, fish that incubate their eggs and young in their mouths. When the cichlid spawns, the cuckoo catfish swiftly lays its own eggs among the host's eggs. The cichlid, unaware of the intrusion, gathers the mixed clutch into its mouth. Inside the protective buccal cavity, the catfish eggs hatch first and the larvae proceed to devour the host's eggs and young, ensuring their own survival at the expense of their foster siblings. Returning to the avian world, the phenomenon of egg mimicry deserves further exploration. It's a testament to the power of natural selection, where the parasite's eggs evolved to closely resemble those of their hosts in color, size, shape, and even patterns. For example, the common cuckoo, a notorious brood parasite, exhibits remarkable egg mimicry, with different cuckoo lineages specializing in parasitizing specific host species and laying eggs that match the host's eggs almost perfectly. The variations are astonishing, ranging from subtle differences in background color to intricate patterns of spots and squiggles. These similarities enhance the chances of acceptance by the host, making it more difficult for the host to distinguish between its own eggs and the parasitic egg. This mimicry, however, sets the stage for an evolutionary arms race, where the host evolves better egg recognition abilities, and the parasite, in turn, evolves even more refined egg mimicry, a continuous cycle of adaptation and counter-adaptation. While much of our discussion has focused on interspecific brood parasitism, where the parasite and host are different species, intraspecific brood parasitism also occurs. This strategy, where a female lays her eggs in the nest of another female of the same species, is common in several duck species, including wood ducks and redheads. In some cases, as with eider ducks, the first and second eggs laid are especially vulnerable to predation, potentially driving females to lay these eggs in other eiders' nests. This behavior can also be a conditional strategy, dependent on environmental conditions or resource availability. For example, when wetland conditions are poor and food is scarce, A female redhead may be more likely to parasitize another redhead's nest, maximizing her chances of producing at least some offspring without investing heavily in parental care. Intraspecific brood parasitism can also be influenced by factors like the availability of suitable nest sites or the female's own condition. If a female is unable to secure a high-quality territory or is in poor physical condition, she may resort to parasitism as an alternative reproductive tactic. The sneaky life of the brood parasite is a testament to the ingenuity of natural selection. These fascinating creatures have evolved a range of adaptations, from egg mimicry to chick-killing behavior, to exploit the parental care of other species. Their parasitic strategies, while often detrimental to the host, represent a successful evolutionary pathway, allowing them to maximize their own reproductive success while minimizing the costs of parenthood. This intricate interplay between parasite and host continues to captivate scientists, offering valuable insights into the complex dynamics of the natural world. Chapter 2. The Art of Deception, Mimicry and Manipulation. The previous chapter unveiled the cunning strategies brood parasites employ to exploit the parental instincts of other species. This chapter delves deeper into the intricate art of deception, exploring the diverse tactics these parasites utilize to fool their hosts, from the initial egg laying to the fledging of the parasitic chick. It's a story of evolutionary one-upmanship, where mimicry and manipulation are key to survival. The foundation of many brood parasitic strategies lies in egg mimicry, a remarkable adaptation where the parasite's eggs evolved to resemble those of its host. This deception is particularly refined in specialist avian brood parasites like cuckoos. Consider the common cuckoo, Cuculus canorus, a notorious brood parasite across Europe and Asia. Different cuckoo lineages specialize in parasitizing specific host species, laying eggs that remarkably mirror the host's eggs in color, size, and patterns. A cuckoo specializing in parasitizing common redstarts, Phoenicurus phoenicurus, will lay eggs that closely match the redstart's speckled blue eggs. This precise mimicry makes it incredibly difficult for the redstart to identify the imposter egg among its own. Another compelling example of egg mimicry comes from Africa, where the tawny-flanked Prinia subflava, faces the deceptive tactics of the cuckoo finch, Anomalospisa imberbis. Female cuckoo finches have evolved a cunning disguise, resembling the harmless southern red bishop, Euplectes oryx, a common bird in the Prinia's habitat. This disguise allows the cuckoo finch to infiltrate the Prinia's territory and access its nest undetected. However, the Prinia is not entirely defenseless. As an evolutionary counter-strategy, Prinias have become more discerning, often attacking both cuckoo finches and southern red bishops, demonstrating a cautious approach to avoid being duped. Beyond visual mimicry, the physical properties of parasitic eggs also contribute to their success. Thicker egg shells are a common adaptation, observed in cuckoos parasitizing great reed warblers, Acrocephalus arundinaceus, and cowbirds targeting a range of host species. Two main hypotheses explain the function of these thicker shells: puncture resistance and laying damage. The puncture resistance hypothesis suggests that thicker shells prevent hosts from puncturing and destroying the parasitic egg. Studies on marsh warblers, Acrocephalus palustris, have shown they damage their own eggs more often when attempting to break cuckoo eggs, but less so when trying to puncture great reed warbler eggs. The laying damage hypothesis proposes that thicker shells enable the parasite's egg to damage host eggs during laying, while protecting the parasitic egg. Research on shiny cowbirds, Molothrus bonariensis, parasitizing house wrens, Troglodytes aden, and mockingbirds, Mimus polyglottos, and brown-headed cowbirds, Molothrus ater, targeting the same hosts, and red-winged blackbirds, Agelaeus phoenicius, supports this hypothesis. When dropped onto host eggs, cowbird eggs caused damage while sustaining little damage themselves. The art of deception extends beyond the egg stage. Parasitic chicks employ a range of strategies to ensure their survival and outcompete their foster siblings. Rapid nestling growth and shorter incubation periods are common adaptations, particularly in cuckoos and honeyguides. Cuckoos, like the common cuckoo, often have internal incubation periods that give their chicks a head start in development. This, combined with a larger yolk providing more nutrients, allows cuckoo chicks to hatch larger than their host siblings, giving them a competitive advantage in the nest. One of the most dramatic examples of chick deception comes from the common cuckoo. Newly hatched cuckoo chicks have an innate instinct to eject the host's eggs from the nest. Using their backs and shoulders, they systematically push the other eggs over the edge, eliminating competition for parental care. This ruthless behavior ensures the cuckoo chick receives all the food and attention from its foster parents. Honey guides employ a different, but equally brutal, tactic. Their chicks are equipped with sharp hooks on their beaks, which they use to kill their foster siblings upon hatching. These hooks are a specialized adaptation for siblicide, a grim strategy that guarantees the honey guide chick's survival. The size mismatch between parasitic chicks and their foster parents often creates comical, yet poignant, scenes. Imagine a tiny, exhausted warbler struggling to feed a gargantuan brown-headed cowbird chick, its beak a seemingly bottomless pit. The warbler parents, driven by their parental instincts, tirelessly work to satisfy the insatiable appetite of the imposter chick, often at the expense of their own fitness. Visual mimicry also plays a role in chick deception. Indigo bird chicks in Africa have evolved markings on the roofs of their mouths that mimic those of their estrilded finch nestmates. These markings exploit pre-existing patterns in finches, possibly used for guiding parents during feeding in the dark. By mimicking these markings, indigo bird chicks deceive their foster parents into providing them with the same level of care as their own offspring. Parasitic chicks often employ additional tactics to outcompete their foster siblings. Some, like cuckoo chicks in reed warbler nests, can mimic the begging calls of an entire brood, soliciting more food from their foster parents. Others exhibit supernormal stimuli, such as bright gapes or exaggerated begging calls, that trigger the parents' feeding instincts. These adaptations ensure the parasitic chick receives a disproportionate share of resources, maximizing its growth and survival. The art of deception in brood parasitism is a testament to the power of natural selection. These parasites have evolved a remarkable array of strategies to exploit their hosts, from egg mimicry to chick manipulation. Their success, while often detrimental to the host, highlights the intricate and sometimes brutal dynamics of the natural world. Chapter 3. A Symphony of Deception, the Evolutionary Arms Race. The story of brood parasitism is not a simple tale of exploitation. It's a dynamic, ever-shifting battleground where parasites and hosts engage in an intricate evolutionary arms race. As parasites evolve increasingly sophisticated methods of infiltration and deception, hosts counter with equally ingenious defenses, creating a fascinating interplay of adaptation and counter-adaptation. This chapter delves into this co-evolutionary tango, exploring the diverse strategies employed by both sides in this ongoing struggle for survival. The parasitic lifestyle, while seemingly advantageous, presents its own set of challenges. Distributing eggs among multiple hosts, a common tactic among brood parasites, mitigates the risk of total egg loss due to predation or host defenses. However, this scattering of offspring necessitates finding and accessing a variety of host nests, a task that requires keen observation and often deceptive tactics. The brown-headed cowbird, a generalist parasite found in North America, exemplifies this strategy. It parasitizes over 220 different host species, from tiny warblers to larger blackbirds, demonstrating its adaptability and widespread impact. This generalist approach, however, contrasts with the specialized parasitism seen in many cuckoo species, where individual females often specialize on a single host species, laying eggs that mimic the host's eggs with remarkable precision. Hosts, facing the constant threat of parasitism, have evolved a diverse array of defenses. Some, like the eider duck, employ a preemptive strategy. Their first and second eggs, particularly vulnerable to predation, are often laid in the nests of other eiders, a form of intraspecific brood parasitism that minimizes the risk of losing their own offspring. Other hosts focus on nest site selection, choosing locations that are difficult for parasites to access, such as cavities, dense vegetation, or even nests built on precarious branches, provides a first line of defense. Weaver birds in Africa take this strategy to the extreme, constructing nests with narrow entrance tubes that can trap invading cuckoos, sometimes leading to the cuckoo's demise as the weaver birds tear it apart. Early incubation is another effective tactic. By starting incubation before the parasite arrives, the host ensures it is present on the nest during the parasite's typical egg-laying window, often early in the morning. This constant presence deters many parasites, which prefer to lay their eggs when the host is away. Aggressive territory defense also plays a crucial role. Hosts that actively patrol and defend their nesting territory are more likely to deter parasites and protect their nests from intrusion. Black-collared barbets in Africa demonstrate this vigilance, teaming up to attack and even kill parasitic lesser honeyguides that venture too close to their nests. Once a parasitic egg is laid, the host's next line of defense is ejection. This requires the ability to distinguish between one's own eggs and the parasite's, a task that can be incredibly challenging due to the parasite's sophisticated egg mimicry. The common cuckoo, for example, exhibits remarkable egg mimicry, with different cuckoo lineages specializing in parasitizing specific host species and laying eggs that closely resemble the host's eggs in color, size, and patterns. This mimicry forces hosts to evolve increasingly refined egg recognition abilities, leading to an escalating arms race. Hosts employ various methods for egg ejection. Some, like the marsh warbler, have evolved larger beaks, enabling them to grasp and remove parasitic eggs. Others, like the western Bonelli's warbler, use their beaks to puncture parasitic eggs, a tactic that minimizes the risk of accidentally damaging their own eggs. However, even with these adaptations, egg ejection is not foolproof. The mimicry employed by parasites can still lead to errors, with hosts sometimes ejecting their own eggs in the process. This cost of error can be substantial, particularly for species with small clutch sizes, highlighting the delicate balance between defense and the risk of self-inflicted harm. Some hosts, faced with the daunting task of egg recognition, resort to nest desertion. Upon discovering a parasitic egg, they abandon the nest and start anew in a different location. This strategy, while effective in some cases, becomes less viable at high parasitism frequencies, as the new nest is also likely to be targeted. Furthermore, nest desertion comes at a cost, as the host loses the time and energy invested in building the original nest and laying its eggs. Other hosts have evolved ingenious nest modification strategies. Some weave over the parasitic egg, incorporating it into the nest structure but preventing it from hatching. Others build a new nest on top of the old one, effectively burying the parasitic egg in any existing host eggs. The American coot exhibits a particularly intriguing behavior, sometimes building a new nest beside the parasitized one, leaving the parasitic chicks to starve while continuing to care for their own offspring in the new nest. The evolutionary consequences of these adaptations are far-reaching. The arms race between cuckoo finches and tawny-flanked prinhas, where the prinhas attack both cuckoo finches and their harmless lookalikes, the southern red bishops, exemplifies the escalating nature of this conflict. Similarly, the evolution of egg signatures, unique patterns on host eggs that serve as identification markers, highlights the sophistication of host defenses. Superb fairy wrens in Australia even teach their embryos a password-like vocalization while they're still in the egg. This vocalization, incorporated into the nestling's begging calls, allows the parents to distinguish between their own offspring and parasitic Horsfield's bronze cuckoo chicks, which cannot learn the password. Despite these defenses, some hosts remain vulnerable to parasitism. The endangered Kirtland's warbler, for example, cannot differentiate between its own eggs and cowbird eggs, making it highly susceptible to parasitism. This vulnerability has contributed to the warbler's decline, highlighting the devastating impact brood parasitism can have on endangered species. The arms race also extends to the chick stage. The common cuckoo's tactic of mimicking the begging calls of an entire brood to solicit more food, and the honeyguide's gruesome chick-killing behavior with its hooked beak, are stark examples of the lengths parasites will go to ensure their offspring's survival. These adaptations, while often disturbing, demonstrate the relentless pressure of natural selection and the diverse strategies that can emerge in the struggle for existence. The evolutionary arms race between brood parasites and their hosts is a testament to the dynamic nature of coevolution. It's a story of constant adaptation and counter-adaptation, where each side strives to gain an advantage in this ongoing battle for survival. This intricate interplay, with its blend of deception, manipulation, and ingenious defenses, continues to captivate scientists, offering a window into the complex and ever-evolving world of nature. Chapter 4. The Mafia Hypothesis, Enforcing Parental Care Through Terror. The previous chapters have illuminated the cunning tactics brood parasites employed to deceive their hosts, from egg mimicry to chick manipulation. But one central question remains. Why do so many hosts, despite recognizing the parasitic intrusion, continue to care for nestlings that are so drastically different from their own? These parasitic chicks often dwarf their foster siblings, their appearance a stark contrast to the host's young. Furthermore, raising these imposters significantly reduces the host's reproductive success, diverting valuable resources away from their own offspring. This seemingly paradoxical behavior has led to the development of a chilling theory, the Mafia hypothesis. The Mafia hypothesis proposes that parasitic adults actively enforce parental care through intimidation and brutal retaliation. It paints a grim picture of a protection racket operating in the avian world, where the price of resistance is steep. If a host rejects a parasitic egg or chick, the adult parasite may return to destroy the entire nest, injuring or even killing the host's own offspring. This threat, hanging like a dark cloud over the host's nest, encourages compliance with the parasite's demands, even at the cost of their own reproductive success. The brown-headed cowbird and the great spotted cuckoo are prime examples of species suspected of engaging in these mafia-like tactics. The great spotted cuckoo, which primarily parasitizes European magpies, exhibits behaviors consistent with the Mafia hypothesis. These cuckoos have been observed repeatedly visiting parasitized nests, not just to lay their initial egg, but to monitor the status of their parasitic offspring. This diligent surveillance suggests an active role in enforcing parental care. Experiments have provided further support for the Mafia hypothesis. Magpie nests from which cuckoo eggs were removed were subsequently destroyed by the cuckoos at a much higher rate than non-parasitized nests or nests where the cuckoo egg remained. This retaliatory behavior strongly suggests that the cuckoos are actively punishing hosts that reject their eggs. An alternative explanation for the cuckoo's nest destruction is that it encourages the magpie to build a new nest, providing another opportunity for parasitism. While this farming hypothesis may play a role, it doesn't fully explain the targeted nature of the nest destruction, focusing specifically on nests where eggs have been rejected. The Mafia hypothesis, with its emphasis on retaliation, offers a more compelling explanation for this targeted aggression. Similarly, studies on brown-headed cowbirds parasitizing prothonotary warblers have provided further evidence of mafia-like behavior. In experiments, nests from which cowbird eggs were removed experienced significantly higher predation rates, 56%, compared to non-ejected nests, 6%. This stark difference suggests that cowbirds actively target nests where their eggs have been rejected. The cost of resistance is evident in the warbler's reproductive success. Hosts that ejected cowbird eggs produced 60% fewer young than those that accepted the parasitic eggs, highlighting the potential cost of defying the cowbird's protection racket. Furthermore, 85% of parasitized nests rebuilt by warblers after initial destruction were subsequently destroyed again, suggesting a persistent campaign of intimidation by the cowbirds. There are more examples of the diverse and often brutal tactics employed by brood parasites. The shiny cowbird, for example, has been observed damaging host eggs during the laying process, while its own thicker shelled eggs remain intact. This aggressive behavior ensures a competitive advantage for the cowbird chick. American coots, when parasitized, sometimes resort to extreme measures. They may kick the parasitic eggs out of the nest or even build a new nest beside the parasitized one, leaving the parasitic chicks to starve while they continue to care for their own young in the new nest. Cuckoo chicks, in addition to egg ejection, employ other manipulative tactics. They often mimic the begging calls of their host's chicks, sometimes even mimicking the sound of an entire brood, to solicit more food from their foster parents. This deceptive behavior ensures they receive a disproportionate share of resources, often at the expense of their foster siblings. Furthermore, the longer internal incubation periods of cuckoo eggs, a unique adaptation, give cuckoo chicks a size advantage upon hatching, allowing them to outcompete their smaller nestmates. The Mafia hypothesis, while compelling, is not without its nuances and ongoing debate. Some researchers argue that the observed nest destruction might be incidental, a byproduct of the parasite searching for new nesting opportunities rather than a targeted act of retaliation. The similarity hypothesis offers an alternative perspective, suggesting that female cuckoos select hosts with eggs similar to their own, implying a focus on mimicry rather than intimidation. Critics of this hypothesis, however, point out that it lacks a clear mechanism for nest selection and fails to identify the specific cues cuckoos use to recognize suitable hosts. Adding another layer of complexity to the narrative are instances where hosts unknowingly raise parasitic offspring. This can occur due to highly effective egg mimicry, as seen in some cuckoo species, or when hosts temporarily abandon their nests after laying, providing an opportunity for parasites to deposit their eggs undetected. Female eiders, for example, sometimes prefer to lay in nests with existing eggs, inadvertently creating opportunities for parasitic egg laying. The Mafia hypothesis, with its chilling implications of enforced parental care, offers a fascinating glimpse into the darker side of brood parasitism. While the debate surrounding the hypothesis continues, the evidence suggests that intimidation and retaliation play a significant role in the interactions between some brood parasites and their hosts. These parasitic birds, with their manipulative tactics and brutal enforcement strategies, highlight the complex and sometimes ruthless dynamics of the natural world. Their behavior, while often detrimental to the host, represents a successful evolutionary pathway, allowing them to maximize their own reproductive success while minimizing the costs of parenthood. Chapter 5. Beyond the Nest: The Broader Impacts of Brood Parasitism. The chilling implications of the Mafia hypothesis, where parasitic birds enforce parental care through intimidation and retaliation, are just one facet of the broader ecological impacts of brood parasitism. This reproductive strategy, with its intricate web of deception and manipulation, has far-reaching consequences that extend beyond the individual nests of hosts and parasites, shaping biodiversity and influencing the ecological dynamics of entire communities. The most immediate and obvious impact is the reduction in host reproductive success. Brood parasites, by outsourcing parental care, effectively steal resources from their hosts, leading to a significant decrease in the number of host offspring that survive to fledging. This isn't just a matter of a few fewer chicks. The studies reveal stark examples of this parasitic burden. Prothonotary warblers, for instance, face a daunting choice when parasitized by brown-headed cowbirds. Those that attempt to resist the parasitism by ejecting the cowbird egg suffer a 60% reduction in their own offspring compared to those that accept the parasitic egg. This stark statistic underscores the effectiveness of the cowbird's mafia-like tactics, as discussed in the previous chapter, where retaliation against egg ejection can devastate a host's reproductive output. The impact on endangered species can be even more severe. The Kirtland's warbler, already struggling with habitat loss, faces an additional threat from cowbird parasitism. Their inability to recognize and reject cowbird eggs makes them particularly vulnerable, exacerbating their conservation challenges. In some cases, parasitism rates can be so high that entire broods of host chicks are replaced by a single, much larger, parasitic chick. The evolutionary impacts of brood parasitism extend far beyond egg mimicry. The constant pressure exerted by parasites has driven the evolution of a diverse array of adaptations in both parasites and hosts, creating an ongoing co-evolutionary arms race. Parasites, for instance, have evolved thicker eggshells, a trait observed in cuckoos and cowbirds. These thicker shells serve multiple purposes. They protect the parasitic egg from damage during the laying process, especially when the parasite forcefully ejects or damages the host's eggs. They also make it more difficult for hosts to puncture and destroy the parasitic egg, a common defense mechanism. Furthermore, parasitic chicks often exhibit faster nestling growth compared to their host siblings. This rapid development, fueled by a larger yolk providing more nutrients and often coupled with longer internal incubation periods, as seen in cuckoos, gives them a competitive edge in the nest. They can outcompete their smaller, slower-growing foster siblings for food, often monopolizing the parent's attention and resources. This accelerated growth also shortens the time the parasitic chick spends in the nest, reducing its vulnerability to predation and other nest-related threats. Specialized begging calls are another adaptation employed by parasitic chicks. Cuckoo chicks, for instance, can mimic the begging calls of an entire brood of host chicks, creating an auditory illusion that deceives the host parents into providing more food. This deceptive tactic ensures the cuckoo chick receives a disproportionate share of resources, maximizing its growth and survival. The indigo bird chicks in Africa take a different approach, mimicking the unique mouth markings of their estrildid finch nestmates. These markings, possibly used by the host parents to identify their young in the dark nest, are exploited by the indigo bird chicks to ensure they receive the same level of parental care. Brood parasitism also has profound impacts on host distribution and abundance, influencing the ecological dynamics of entire communities. While it's true that hosts may avoid areas with high parasite densities, researchers provide more nuanced insights into these impacts. Range shifts can occur when host populations decline in areas of high parasitism and increase in areas where parasites are less common. This can lead to changes in community structure, potentially affecting the distribution and abundance of other species that interact with the host. The cuckoo catfish, for instance, exerts a significant impact on the mouth-brooding cichlids of Lake Tanganyika. The catfish's parasitic behavior, where its young devour the host's eggs and young inside the cichlid's mouth, can severely reduce cichlid reproductive success. This, in turn, can affect the population dynamics of the cichlids, potentially leading to declines in their numbers and influencing the overall fish community structure in the lake. The concept of the evolutionary trap is particularly relevant in the context of brood parasitism. Behaviors that were once adaptive for hosts, such as the instinct to care for any chick in the nest, can become maladaptive in the presence of brood parasites. This instinct, honed over millennia to ensure the survival of their own offspring, is exploited by parasites, who benefit from the host's indiscriminate parental care. Similarly, nest desertion, an effective defense against some predators or environmental changes, becomes less effective at high parasitism rates, as the new nest is also likely to be targeted. This creates a vicious cycle, where the host's attempts to escape parasitism are continually thwarted, trapping them in a situation where their previously adaptive behaviors now contribute to their reproductive decline. Naive hosts, those with no co-evolutionary history with a particular brood parasite, are often especially vulnerable. Lacking the specific defenses that have evolved in hosts with a long history of interaction with a parasite, they are more likely to accept parasitic eggs and raise parasitic chicks, often at a significant cost to their own reproductive success. This is evident in the case of the Kirtland's warbler, which has not evolved defenses against the brown-headed cowbird and suffers high rates of parasitism. In contrast, hosts with a long co-evolutionary history with a parasite have often evolved specific defenses, such as egg recognition and rejection, nest defense behaviors, and even chick discrimination. The tawny-flanked Prinia's aggressive response to both cuckoo finches and their harmless look-alikes, the southern red bishops, is a testament to this co-evolutionary arms race. The unique egg signatures employed by some host birds, such as the intricate patterns on the eggs of weaver finches and warblers, provide a fascinating example of a co-evolved defense. These signatures, virtually impossible for parasites to mimic perfectly, allow the host to readily identify and reject parasitic eggs. Similarly, the password-like vocalizations taught by superb fairy wrens to their embryos, a vocal password that Horsfield's bronze cuckoo chicks cannot learn, demonstrate the sophisticated adaptations that can arise in response to brood parasitism. Brood parasitism, with its deceptive tactics, manipulative strategies, and far-reaching ecological consequences, is more than just a curious oddity of the natural world. It's a powerful evolutionary force that shapes biodiversity, influences host-parasite coevolution, and can even drive the decline of vulnerable species. Many studies paint a vivid picture of this complex interplay, highlighting the diverse adaptations and counter-adaptations that emerge in this ongoing struggle for survival. From the intricate egg mimicry of cuckoos to the brutal chick-killing behavior of honeyguides, the stories of brood parasitism offer a captivating glimpse into the intricate and sometimes ruthless dynamics of nature. Brood parasitism, a reproductive strategy where one species tricks another into raising its young, reveals a fascinating world of deception, adaptation, and co-evolution. From egg mimicry to chick manipulation and even mafia-like enforcement tactics, brood parasites have evolved an arsenal of strategies to exploit their unsuspecting hosts. These parasites, ranging from birds and insects to fish, demonstrate the remarkable ingenuity of natural selection. Hosts, in turn, have evolved defenses like egg recognition, nest desertion, and aggressive nest protection, creating a dynamic evolutionary arms race. This parasitic relationship has significant ecological consequences. It reduces host reproductive success, influences host distribution and abundance, and can even lead to evolutionary traps, where previously adaptive behaviors become detrimental in the presence of parasites. The vulnerability of naive hosts, lacking co-evolved defenses, highlights the importance of evolutionary history in shaping these interactions. The drastic impact on endangered species, like the Kirtland's warbler, underscores the conservation implications of brood parasitism. The research highlights the complexity of co-evolution, showcasing how the constant pressure from parasites drives adaptation in both parasites and hosts. The evolution of thicker eggshells in parasites, faster nestling growth in parasitic chicks, and specialized begging calls are just a few examples of the remarkable adaptations that arise in this ongoing arms race. Hosts, in turn, have evolved intricate defenses like egg signatures and even password-like vocalizations to identify and protect their own offspring. These findings contribute significantly to our understanding of evolutionary biology, ecology, and animal behavior. They shed light on the intricate relationships between species, the dynamics of co-evolution, and the far-reaching consequences of parasitic interactions. These insights can inform conservation efforts, particularly for endangered species vulnerable to brood parasitism. Furthermore, understanding the mechanisms of mimicry and manipulation in brood parasites could have applications in other fields, such as robotics and artificial intelligence. Looking ahead, further research could explore the genetic basis of these adaptations, the role of environmental factors in influencing parasitic behavior, and the long-term consequences of brood parasitism on ecosystem dynamics. Investigating the nuances of the Mafia hypothesis, including the potential for alternative explanations, will further refine our understanding of the complex interplay between parasites and hosts. What are your thoughts on these cunning reproductive strategies? Have you witnessed any examples of brood parasitism in your own backyard? Share your observations and questions in the comments below. Don't forget to like, subscribe, and suggest topics for future explorations. The natural world is full of wonders, and the pursuit of knowledge is a journey worth taking. Keep exploring, keep questioning, and keep learning.